Make me a host. Make me a host. Thank you. In the last class, we learned law of multiple proportion. We will continue from that. One or two more problems will work and then continue. The law of multiple proportion states when two elements combine to form two or more compounds in which fixed weight of one element combines with different weights of other elements will be in simple numerical ratio. We have taken two examples. One we spoke with hydrogen and the other one with respect to carbon. The third example, if you can observe here, we have sulfur dioxide. Sulfur dioxide and sulfur dioxide. Sulfur dioxide, 32 grams of sulfur reacts with 32 grams of oxygen. In case of sulfur trioxide, 32 grams of sulfur reacts with 48 grams of oxygen. So sulfur mass is fixed, but oxygen mass varies. So this is called as law of multiple proportion. The statement is very clear. When two elements combine to form two or more compounds in which fixed weight of one element combines with different weight of other elements and in simple ratio. So the ratio here will be 1:1 and here the ratio will be 2:3. 2:3. Here the ratio is 2:3. Now from that, we worked a few problems. We'll work the second problem here. Carbon is found to form two oxides, which contains 42.9% carbon, 42.9% and 27.3% carbon respectively. Show that these figures illustrate law of multiple proportion. Now, what is the first step? First step is to calculate the percentage composition of carbon and oxygen. Now, for clearly the question is carbon is found from two oxides. So we have marked it as the first oxide and we have marked it as the second oxide. In the first oxide, carbon is 42.9%. If carbon is 42.9%, then what's the percentage of oxygen? The percentage of oxygen will be 100 minus 42.9. That will be 57.1. So in the first case, the percentage of oxygen is 57.1. In the second oxide, the percentage of carbon is 27.3. The second case, percentage of carbon is 27.3. Therefore, percentage of oxygen will be 100 minus 27.3. That will be equal to 72.7. So in the second case, since the question clearly says 27.3% carbon will be there, so the rest will be oxygen. The second step in the question, to calculate the mass, they're asking carbon is found to form two oxides, which contain 42.9% and 27.3% carbon respectively. Show these figures illustrate law of multiple proportion. In order to prove that, the second step, to calculate the mass of carbon, which combined with the fixed mass, that is 1 part by mass of oxygen in each of the two oxides. Now 57.1% oxygen or parts by oxygen combined with 42.9. That is what in the first case we have learned. 42.9% carbon and 51.7%. What we can say is 57.1% of oxygen combines with 42.9% carbon, according to this. So that is the statement. 52.1 parts by mass of oxygen combined with 42.9. So therefore, if one part of oxygen has to combine, one part, so it's cross multiplication. 1 into 42.9 divided by 57.1, that is equal to 0.751. That's equal to 0.751. In the second case, 72 parts by mass of oxygen combined with 23 parts of carbon. Combined with carbon, 27.3% parts of carbon. Therefore, one part of oxygen will combine with what? How many number of parts of carbon? So it will be 1 into 27.3 divided by 72.7. That will be equal to 0.376. Second case. Now, to compare the mass of carbon, which combined with the same mass of oxygen in both the oxides, the ratio of mass of carbon that combines with the same mass of oxygen, one part is 0.75 to 0.376. So you can see here 0.75 to 0.376. So it will be 2:1. Since this is a simple whole number ratio, the above data illustrates law of multiple proportion. So the ratio is 2:1. The next law, that is called as law of a reciprocal proportion. Law of reciprocal proportion. When two elements combine separately with fixed mass of the third element, then the ratio of their masses in which they do so is either the same or some whole number multiple of the ratio in which they combine with each other. We will take an illustration and work. Now, the statement clearly says, the law says, when two elements combine separately with the fixed mass of third element, then the ratio of their masses in which they do so is either same or some whole number multiple of ratio in which they combine with each other. This law may be illustrated with the help of the following example. The first example here is the elements carbon and oxygen. The element carbon and oxygen combine separately with the third element. So carbon combines with hydrogen to form methane. The third element is hydrogen. The first element is carbon. The second element is oxygen. The third element is hydrogen. So carbon reacts with the third element to form methane, and oxygen reacts with the oxygen, second element. Oxygen reacts separately with the third element. Oxygen reacts with hydrogen to form water. This reaction can be written as O2 plus 2H2, giving you 2 moles of water. And they combine directly with each other. The first two elements combine directly with each other to form carbon dioxide, as shown. This is what. See, first element is carbon, the second element is oxygen, the third element is hydrogen. Now, carbon reacts with the third element to form methane. The second element, oxygen, reacts with the third element, hydrogen, to form water. Now, the first and the second element combine with each other to form carbon dioxide. So, the statement is clear. When two elements combine separately with a fixed mass of the third element, then the ratio of their masses in which they do so is either same or the whole number. So the ratio here in case is 1:, not 1:, 12:4, because atomic mass of carbon is 12 and hydrogen is 4 here, 2 moles. So or we can write 3:1. In the second case, we can write 1:2, or we can write it as what? We can write it as 1:2, 1:2 only. We can take this as what? 1:2. So you can see here 3:1, hydrogen is 1. Here also maybe we can write 0.5:1. The same ratio or some whole number. Here it is some whole number of the ratio in which they combine with each other. They take the second illustration. In methane, 12 grams of methane, 12 parts by mass of carbon, 12 grams of carbon combines with 4 parts by mass of hydrogen, or 4 grams of hydrogen. Now, in carbon dioxide, 12 grams of carbon or parts per mass of carbon combines with 32 parts by mass of hydrogen, or 32 grams of parts by mass of oxygen. It's not hydrogen, it's oxygen. 32 grams of oxygen. Now, in case of water, 2 grams of hydrogen, or 2 parts per mass of hydrogen, 2 grams of hydrogen, combines with 16 parts by mass of oxygen, or 16 grams of oxygen. Thus, the mass of carbon, oxygen, which combines with fixed mass of hydrogen, say 4 parts by mass, are 12 and 32. 12 and 32. So 12 grams of carbon combines with 12 grams of carbon and say 4 parts by mass are 12 and 32. So 12 grams of carbon combines with 4 parts of hydrogen, or 32 parts of oxygen combined with 4 parts of hydrogen. Because we have learned here, 12 here in this statement I gave. So here this 32 grams of oxygen combining with 4 grams of hydrogen. That is the statement what has been told here. So that is, they are in the ratio 12:32. 12:32. 12 grams of carbon, 32 grams of oxygen, or 3:8. Now, in carbon dioxide, 12 parts by mass of carbon combine directly with 32 parts by mass of oxygen. That is, they combine directly in the ratio 12:32 or 3:8. In the third example, carbon dioxide formation, carbon plus oxygen giving you carbon dioxide. 12 grams of carbon combines with 32 grams of oxygen. Again, the ratio is 3:8. This is called as law of reciprocal. Now, illustration. The second illustration, the element hydrogen, oxygen combines separately with the third element. Third element is sulfur. The first element is hydrogen. The second element is oxygen. The third element is sulfur. So hydrogen and oxygen combines. Hydrogen combines with sulfur, third element. Oxygen combines with the third element, sulfur, to form hydrogen sulfur. Hydrogen combine with the sulfur to form hydrogen sulfide. Oxygen combines with the third element, sulfur, to form sulfur dioxide. There's a product here written, sulfur dioxide. And these elements, what are these elements? The first and the second element, hydrogen and oxygen combines to form water directly. The mass of hydrogen and oxygen, which combines with a fixed mass of sulfur, 32 parts, are 2:32. So that means in this case, 2 grams of hydrogen combines with 32 grams of sulfur. That is, they are in the ratio 2:32 or in the ratio 1:16. When hydrogen and oxygen combine directly to form water, so when hydrogen and oxygen combine directly to form water, the ratio of combining is 4:32. Since we are taking 2 moles, we can write it as 2:16, or we can write it as 1:8. 1:8. the two ratios are related to each other. The first case, it is 1/16. The second case, it's 1/8. That is, they are in the simple multiple of each other. Third problem, similar third problem. We'll skip the third problem and go to the next law. Now, Gay-Lussac's law. What is this Gay-Lussac's law of combining volumes? At similar conditions of temperature and pressure, when gases do react with each other, the volumes of the reacting gases as well as products are in the simple whole number ratio. At similar conditions of temperature and pressure, similar conditions of temperature and pressure, whenever gases do react with each other, they do in terms of volumes. And the gases reacting as well as the product formed are in simple ratio. So otherwise we can say at the same temperature and pressure, volume of gases, gaseous reactants reacted and volume of gaseous product formed, they're a simple ratio. So two ways we can state Gay-Lussac's law of combining volume. What is Gay-Lussac's law? At similar conditions of temperature and pressure, when gases do combine with each other, they do combine in terms of volumes in simple ratio. Now, for an example, hydrogen is a gas, oxygen is a gas. Hydrogen and oxygen, they combine to form water. Water is a vapor, we say it is a gas. Now, what is the statement says? At similar conditions of temperature and pressure, different gases react with each other to form a product in simple ratio. That is 2 liters of hydrogen or 2 volume of hydrogen combined with 1 volume of oxygen to form 2 volumes of water. Or you can say here another example, 1 liter of nitrogen reacts with 3 liters of hydrogen to form 2 liters of ammonia. So the ratio is 1:3:2. So Gay-Lussac's law states at similar conditions of temperature and pressure, gases do react with each other in terms of volumes to form a product in which the reactants and products are in simple whole number ratio. Next is Avogadro's law. Now, what is this Avogadro's law? Now, in order to understand Avogadro's law, we'll introduce a term called as mole. Mole concept is a different topic, an elaborate topic we'll have to learn. Now, in order to understand Avogadro's law, we will introduce a term called as mole. Now, what is a mole? Now, for an example, if you take carbon, the atomic mass of carbon is 12. So, if we take 12 grams of carbon, this 12 grams of carbon will contain 6.022 into 10 to the power 23 carbon atoms. This number is called as Avogadro's number. It's represented as Na. Likewise, if you take oxygen, O2, oxygen exists as O2 molecule. Now, the molecular mass of oxygen is 32. Atomic mass is 16, 16 into 2 is 32. 32 grams of oxygen, if we weigh and find out, it also contains 6.022 into 10 to the power 23 oxygen molecules. Similarly, if you take carbon dioxide, it is a molecule. Carbon is 12, oxygen is 32. So therefore, totally the molecular mass is 44. 44 grams of carbon dioxide, if you weigh and find out the number of carbon dioxide molecule, it will contain 6.02 to 10 to the power 23 carbon dioxide molecules. So mole is defined as weight of substance which contains Avogadro's number of particles. So 12 grams of carbon contains Avogadro's number, 6.02 to 10 to the power 23 carbon atoms. Therefore, 12 grams of carbon will be called as 1 mole. 32 grams of oxygen also contains 6.022 in 10 power 23 oxygen molecule. Therefore, 32 grams of oxygen is also called as 1 mole. So if you take 44 grams of carbon dioxide, this also contains 6.022 in 10 power 23 carbon dioxide molecule. Therefore, 44 grams of carbon dioxide will also be called as a mole. A mole is defined as amount of substance containing Avogadro's number of particles. Avogadro's number of particles. Say particles can be atoms or molecules, or it also can be ions. Now we have to understand something called as molar volume. Molar volume. The next concept you have to understand is molar volume. What is this molar volume? Volume occupied by 1 mole of a gas. Volume occupied by 1 mole of a gas is called as molar volume. Now what we will do is, here they've taken helium, oxygen and nitrogen. We will not take helium, oxygen and nitrogen. We will take some oxygen and carbon dioxide for our understanding. So we'll ignore this. For now, we'll ignore this is helium. So, and this is, we'll mark it as carbon dioxide. So we have taken 32 grams of oxygen and we have filled it in a balloon at STP, standard temperature and pressure. And we have taken 1 mole of carbon dioxide. 1 mole of carbon dioxide, that is 44 grams. Now, the volume of this balloon will be 22.4 liters. So if we fill 32 grams of oxygen into the balloon at STP, or 44 grams of carbon dioxide at STP, or 28 grams of nitrogen at STP, 28 grams of nitrogen is 1 mole at STP, the volume, the total volume occupied by these gases will be 22.4 liters. This 22.4 liters is called as molar volume. Molar volume. STP, when we say temperature is 273 Kelvin and pressure is 1 atmosphere, standard temperature and pressure, that's called as STP. So molar volume is volume occupied by a gas, volume occupied by 1 mole of gas at STP. At STP, standard temperature and pressure, is called as molar volume. Now, what is this Avogadro's law? In order to understand Avogadro's law, we are going to redo this. When we say redo this, now we'll take 22.4 liters of oxygen. Now, this 22.4 liters of oxygen is 1 mole, and that 1 mole occupies what volume we learned? 22.4 liters. So 22.4 liters of oxygen at STP contains 6.022 into 10 power 23 oxygen molecules. Likewise, if you take 44 grams of carbon dioxide, this 44 grams of carbon dioxide at STP occupies 6.022 into 10 power 23 carbon dioxide molecules. So this is nothing but Avogadro's law. What is this Avogadro's law? Equal volumes of different gases. No, sorry, I made a mistake. It's not this 22.4 liter. Here also I should have taken in terms of liter and explain. I took in terms of volume and explain. Sorry. So this is also in terms of liter. So 22.4 liters of carbon dioxide. This 22.4 liters of carbon dioxide also contain 6.022 in 10 power 23 carbon dioxide molecule. This is Avogadro's hypothesis or Avogadro's law. What is this Avogadro's hypothesis or Avogadro's law? At similar conditions of temperature and pressure, similar conditions of temperature and pressure, equal volumes of different gases different gases contains same number of molecules. Same number of molecules. See, oxygen is a different gas, carbon dioxide is a different gas. Volume is same. 22.4 liters of oxygen, 22.4 liters of carbon dioxide. Both contains 6.022 at 10 power 23. In the first case, oxygen molecule. In the second case, carbon dioxide molecule. This was called as Avogadro's law. Equal volumes of different gases at similar conditions of temperature and pressure contains same number of molecules. Now, applications of Avogadro's law provides a method to determine the atomic weight of gaseous element. It helps out to determine the atomic weight of gaseous elements. And similarly, it provides a relationship between vapor density and molecular mass. This relationship is important. This relationship for competitive exam, it is important. So molecular weight is equal to 2 into vapor density. So this experiment was there in the previous syllabus. We don't have this experiment. So need not have to learn the derivation. You have to remember this formula. Molecular weight is equal to 2 into vapor density, or we can write vapor density is equal to molecular mass by this formula you should remember. Next, the third application, it helps in determination of mass of fixed volume or molar volume of a gas. Mass of 1 ml of a gas is vapor density into 0.0000897 grams. So 2 into vapor density is nothing but molecular mass. 2 into vapor density is molecular mass. Molecular mass will be equal to 1 into 2 into vapor density divided by vapor density into 0.0000897 ml. That is 22,400. So molar mass of a gas or its 1 mole occupies 22.4 liters. This calculation is also not necessary. So you should remember what is molar volume. Molar volume is volume occupied by 1 mole of a gas. Volume occupied by 1 mole of a gas at STP is called as molar volume, and it has a value 22.4 liters, or in terms of milliliters, we can write 22,400 milliliters. The fourth application, it helps in determination of molecular formula of gases and is very useful in gas analysis. By knowing the molecular volumes of the reactants and products of reaction, molecular composition can be determined. So fourth application of Avogadro's law is the determination of molecular formula of gases. Now, the next is Dalton's atomic theory. Dalton's atomic theory. The main postulates of Dalton's atomic theory. Dalton proposed the model of an atom. So that's called as Dalton's atomic theory. So we are going to learn the atomic model, various atomic models possibly in the chapter atomic structure of an atom. But here are basic concepts, also few concepts about the atomic theory we're going to learn. And the first one is called as Dalton's atomic theory or Dalton's atomic model. So matter, as we learned, matter is something which occupies space and volume. Matter is something which occupies space and volume, which has a definite, definite mass and volume. Definite space and mass will be called as matter. So matter is made up of extremely small, indivisible particles called as atoms. It's not individual, indivisible. Atoms cannot be divided. That was the proposal given by Dalton. So in modern days, we know that atom can be divided into subatomic particles like electrons, protons, and neutrons. When science was emerging in olden days, so Dalton proposed that matter is made up of small, indivisible. That means a particle which cannot be divided, and those he termed it as atoms. The first postulate in atomic theory is matter is made up of small, minute, indivisible particles called as atoms. The second postulate is atoms of same elements are identical in all aspects. Atoms of same elements. So hydrogen molecule, if you take this hydrogen molecule contains two hydrogen atoms. So this hydrogen atom and this hydrogen atom is identical in all aspects, size, shape, energy, all that will be same. That's the second point. Atoms of the same element are identical in all respects. Now, again, if you take one more example, oxygen. Oxygen is a molecule which contains oxygen atoms. This oxygen atom will behave or will have same properties as the other oxygen, the second oxygen atom. So atoms of the same elements are identical in all aspects, shape, size, reactivity, energy, all that. The third postulate is atoms of different elements are different in all respects and have different masses and chemical property. Now, if you take carbon monoxide, if you take for an example, so carbon is different, oxygen is different. Since carbon and oxygen are different, they will have different atomic mass. Carbon has atomic mass 12 and oxygen has atomic mass 16. The reactivity of carbon and oxygen will be different. The size of carbon and oxygen will be different. The third point is atoms of different elements are different in all respects, in all aspects, size, shape, reactivity, all that. Now, the next point is atom is the smallest unit that takes part in the chemical combination. So, atoms are the smallest unit which takes place in chemical combination or in chemical reaction. The fourth postulate of Dalton is atom is the smallest particle which take part in chemical reaction. The fourth postulate we have learned, matter is made up of extremely small, indivisible particles called as atoms. The second point is atoms of the same elements. Atoms of the same elements are identical in all respects. Next, the third point, atoms of different elements are different in all respects and have different masses and chemical properties. I gave an example. Carbon monoxide is a CO. It has two different atoms. One is carbon, the other one is oxygen. Carbon atomic mass is 12, oxygen atomic mass is 16. The reactivities are different. Physical properties are different. And the fourth point is atom is the smallest unit that takes place in the chemical combination or chemical reaction. The fifth postulate of Dalton's theory is atoms of two or more elements combine in simple whole number ratio to form a compound. Atoms of two or more elements combine in simple whole number ratio to form a compound atoms. A simple example, water. Water is a combination of hydrogen and oxygen. Half a mole of oxygen. We can write this as 2:1. So two hydrogen atom combined with one oxygen atom to form water. That is what they say. Atoms of two or more elements combine in simple whole number ratio to form a compound. Atom can be neither created nor destroyed during any physical or chemical change. So the sixth is atoms can be neither created nor destroyed. Chemical reactions involve only combination, separation, rearrangement of atoms. What do you mean by chemical reaction according to Dalton? It is the combination of atoms, it is the separation of atoms, and or the rearrangement of atoms. These are the postulates of Dalton's theory. One more time, we will just go through the postulates of Dalton's theory. The first one is matter is made up of extremely small, indivisible particles called as atoms. The second point, atoms of the same elements are identical and are same in all respects, size, shape, all that. Physical and chemical properties will be same for same elements. So atoms of different elements are different in all respects. They have different masses and chemical properties. That is, different masses with respect to physical property. Chemical properties are reactions. Atoms is the smallest unit that takes place in the chemical reaction. The next is atoms can neither be created nor destroyed during any physical or chemical change. And chemical reactions involve only combination, separation, or rearrangement of atoms. What are the limitations of Dalton's theory? The limitations of Dalton's theory are the demerits of Dalton's theory. Limitations, otherwise it is also called as demerits, or it's also called as drawbacks. Drawbacks of Dalton's theory. The few of the drawbacks, limitations you have to remember. Atoms was no more indivisible. Atoms was no more indivisible. It is made up of various subatomic particles like electrons, protons, and neutrons. So now atoms can be divided into subatomic particles like electrons, protons, and neutrons. So Dalton said atoms are indivisible. But now in modern days, we know that atoms can be subdivided. It failed to explain how atoms of different elements differ from each other. So Dalton's theory of an atom or atomic theory fails to explain how different elements differ from each other, how oxygen differ from nitrogen, how nitrogen differ from carbon. So that explanation was not given by it. The third, it failed to explain how and why atoms of elements combine with each other to form a compound. So why a chemical bond is formed, or why a chemical reaction is taking place between two different elements was not explained by atoms. Why elements of different atoms of different why atoms of different elements has to combine to form compounds was not explained, or no insight was given why chemical reaction takes place. The next demerit of Dalton's theory is failed to explain the nature of forces that bind together, the nature of chemical bonds. Forces that bind means chemical bond, which binds together different atoms in a molecule. So he failed to explain the type of bonding between hydrogen and oxygen in water, failed to explain the type of bonding between carbon and oxygen in water, failed to explain the type of bonding between nitrogen and hydrogen in ammonia. So that is what Dalton failed to explain, the type of forces that bind different atoms together in a molecule. And he failed to explain Gay-Lussac's law of combining volumes. So Dalton's law failed to explain Gay-Lussac's law of combining. And it did not make any distinction between ultimate particle of an element that takes part in the reaction, atoms, and the ultimate particle that has independent existing molecule. So Dalton's law fails to explain the difference between atoms and molecules in simple words. So these are the demerits or limitations of Dalton's atomic theory. Now we'll have to work some of the problems based on the laws, what we have learned. Now 12 grams of carbon combines with 64 grams of sulfur to form carbon disulfide. We can write like this: CS2, carbon plus sulfur gives carbon disulfide. The first case. The second case, this is 12 grams of carbon and 64 grams of sulfur. Second one is 12 grams of carbon combines with 32 grams of oxygen, 32 grams of oxygen to form carbon dioxide. The next one is 10 grams of sulfur reacts with 10 grams of oxygen to form sulfur dioxide. See, these data illustrate law of multiple proportion, law of definite proportion, law of reciprocal proportion, law of gaseous volume. Surely it is not law of gaseous volume because carbon and sulfur are solid. So law of definite proportion, law of multiple proportion. Law of multiple proportion is not possible. So maybe if you consider single element here, but here also it is different. So if we say carbon reacts with oxygen and carbon reacts with oxygen like this, 12 grams and 16 grams and 12 grams and 32 grams, then we can say law of multiple proportions. So therefore, this is also not law of multiple proportion. Law of definite proportion, surely it is not possible. Because now 32, as per the formula of sulfur dioxide, it is 32 grams of sulfur and 32 grams of oxygen. So 32 grams of oxygen. So that means 10 grams they have given. The ratio is same. Here the ratio is 1:1. 32 grams is the atomic mass of sulfur and molecular mass of oxygen is 32. So 1:1 ratio. Here also 1:1 ratio. Therefore, this will be called as law of multiple proportion. This will be surely called as law of multiple proportion. Here the third element concept is not there. All right. So it is law of multiple proportion. The answer is A, of multiple proportion. Which of the following data illustrates law of conservation of mass? Now the first one is 56 grams of carbon monoxide reacts with oxygen to produce carbon dioxide. So they say 44 grams of carbon dioxide, 32 grams of oxygen, and 56 grams of carbon monoxide. This is the first case. The second case is silver nitrate reacts with 100 ml of 0.1 normal NaCl, 100 ml of 0.1 normal NaCl to form silver chloride and nitric acid. The third illustration, they've given silver nitrate is 1.70 gram, and here it is sodium chloride. We have to find out and produce 1.435 grams, and to form 0.63 grams. It is not nitric acid, it should be sodium nitrate. It is NaNO3, sodium nitrate. The third example is 12 grams of carbon. When heated in vacuum and on cooling, there is no change in mass. No change in mass. And fourth is none of the above. Fourth is none of the above. So here there is no reaction taking place. In the third case, there is no reaction. Heated in vacuum and cooling, there is no change. So carbon heating in vacuum, no oxygen, no reactions taking place. Therefore, this will not be called as law of conservation of mass. Here also it is not law of conservation of mass because the reactant is 56 plus 32, it is 88 grams. And here it is only 44 grams. So therefore, the first option is also ruled out. The next option, if you see, silver chloride formed is 1.435 grams. And 1.70 grams of silver nitrate. So here you can see sodium chloride is 100 ml of 0.1 normal. 100 ml of 0.1 normal. Sodium chloride molecular mass is 53.5. So they are given the normality 0.1, weight, molecular weight is 58.5, not 53. Sodium is 23, 58.5. Into 1,000 divided by 100, this is 10. So we will have 5.85 divided by 10. It will be 0.585 grams. So sodium chloride will be 0.585 grams. So what will be sodium nitrate? Sodium nitrate formed will be sodium nitrate. Here, sodium nitrate formed will be 1.70 plus 5.585. So it will be 58, which is 2.25, 28. So 2.28 minus 1.435. There will be 0, 5, and 12, 0.8. So it will be 0.850 grams. Sodium nitrate. Therefore, the mass of reactant and mass of product will be same. Therefore, the answer for this question is option B. The law of conservation of mass will be P. If law of conservation of mass was to hold true, then 20.8 grams of barium chloride reacts with 9.8 grams of sulfuric acid, will produce 7.3 grams of HCl and barium sulfate equal to. So this is a simple reaction. Barium chloride with sulfuric acid gives HCl and we get barium sulfate. So as per the question, 20.8 grams of barium chloride and 9.8 grams of sulfuric acid gives 7.3 grams of HCl. So 20.8 plus 9.8 is 30 grams, 30.6. So total mass is 30.6. So now in order to find the barium sulfate formed, it 30.6 minus 7.3. So it will be 23.3. So the amount of barium sulfate formed is 23.3 grams. So the answer will be option B. Next question. 1.5 grams of hydrocarbon on combustion with excess of oxygen produce 44 grams of carbon dioxide, 4.4, I think, 4.4 grams of carbon dioxide and 2.7 grams of water. The data illustrates 1.5 grams of hydrocarbon. Now, for an example, if you take methane it's 1.5 grams and it's heated with oxygen. For combustion, we need oxygen. We get carbon dioxide and water. This is 2.7 grams and this is 4.4 grams. This data illustrates law of conservation of mass, law of multiple proportion, law of constant composition, law of reciprocal proportion. So only two reactions are there. So it is not reciprocal proportion nor multiple proportion. It should be law of constant composition or law of conservation of mass. Now 1.5 grams of hydrocarbon when allowed to react with oxygen, you get 4.4 grams of composition, carbon dioxide and 2.7 grams of water. It can be either law of conservation of mass or law of constant composition. So the ratio here also, if it has to 1.5 grams, maybe 16 grams of methane reacts with 32 grams. This is the molecular mass of methane and molecular mass of oxygen. So that means 1.5 grams of methane means what is the mass of oxygen? So it will be 48. So 4.4 plus 2.7 is equal to 7.1. 7.1 minus 1.5 is 6 and 5.6. So it should be 5.6. The ratio should be same. 1:2. No. So it is not law of conservation of mass because this ratio should be the mass taken. So here the ratio of methane and oxygen is 1:2 ratio. So here it's more than 1:2. Therefore, it cannot be law of mass of conservation of mass. It is law of constant composition. Therefore, the answer is option C. Next question. Two elements X, atomic mass 16. X, atomic mass is 16. Y, atomic mass is 14. Combine to form compound A, B, and C. The ratio of X in A, X in B, X in C are 1, 3, and 5. 32 parts of, or 32 grams of X combines with 84 grams of parts of Y, then 16 parts of X, 16 grams of X will combine with. See, the question is very simple here. X is at 16 and Y is 14. They are clearly saying here 32 parts of X combines with 82 parts of Y by mass in B. Then in C, 16 parts of by mass of X will combine with. So half of it. So it will be 42. 32 and 84. 32 grams in 84. Half of 32 is 16. So here also it should be half of it. Therefore, it will be 42 parts by mass of Y. This is the exercise. Law of multiple proportion illustrated by water, heavy water, calcium hydroxide, barium hydroxide. Law of multiple proportion. Carbon and carbon monoxide and carbon dioxide. Carbon, 12 grams of carbon and 16 grams of oxygen gives you carbon monoxide, 28 grams. 12 grams of carbon and 32 grams of oxygen gives carbon dioxide, 44 grams. So one is fixed here. Mass of carbon is fixed. Mass of oxygen is varying. Therefore, this is called as law of multiple proportion. So the answer A will be the example A will illustrate law of multiple proportion. The next question. Hydrogen and oxygen combine to form water and hydrogen peroxide containing 5.93% and 11.2% hydrogen respectively. The data illustrates. Data illustrates. I think this is hydrogen peroxide and this is water. First one is hydrogen peroxide and the other one is water. So here you can see 5.93 and 11.2. Almost the percentage of hydrogen is double. This illustrates law of conservation of mass, law of constant proportion, law of reciprocal proportion, law of multiple proportion. It should be law of conservation of mass. Law of conservation of mass. Oxygen combines with two isotopes of carbon question I'm not going to read. So law of conservation of oxygen combines with two isotopes of sorry for this, there's problem. I'm not able to read the questions. These exercise problems you can try at home. We will learn with the basic concepts like atoms, molecules, atomic mass, all that's in a different